Hello and welcome to the presentation of Team Advantest. My name is Anthony Vendetti.
My name is Liliana.
My name is Simon.
My name is Zhijie.
And my name is Amy.
My name is Huanji.
We work in collaboration with Advantest, the company liaison, who uses machine learning to detect defect type in the manufacturing test socket lines. The customers expect reliability and good electrical contact for communication and control system application. How we can see here, we study a pin with hexagonal shape, which have 6 sides. Since defects are visually identified by quality engineers, we can use machine learning to perform the same task automatically instead of doing that manually. As we can see here, the good pin or no defective pin is the one that we can see completely over the picture, and we can see the structure that is a hexagonal shape. However, when there is no pin inside the hole, we call this a missing pin or black hole. Also, when there is external particles or external material over the pin, we call this foreign material defect type. And when the camera cannot focus well the pin, we call this out of focus.
And in this program, we have 2 solid problems. The first is the issue of the number of defect images. As shown in Table 1, we divide the images into 4 categories: good, out of focus, missing pin, and foreign material. There are a large number of images of good type, while the number of images of other defect types is very rare. The second problem is shown in Table 2. We need to improve our accuracy. And I want to say that actually we have more than 3 defect types, just like we described before.
The team decided to tackle the problem in 3 different routes. 1, we want to improve the camera ability to capture images, as shown in green. We want to reduce the amount of time it takes for the data to get to the cloud, as shown in blue. And in orange is our route to implement machine learning to detect defects.
For now, we have 1,600 total images. Among these big image dataset, we use our rule set to classify all images. So our result is that there are 88% of good images, which account for the large part. 65 defect images of foreign material, 88 out of focus images, 33 round pin images, and 10 missing pin images. The goal of image preprocessing about cropping images is to reduce the complexity of images and improve our model performance. When we train the model, the background noise in the pinhole image will cause complexity computation, also increase the computation time. What we need to do is to cut the image and keep the important part. For us, we only focus on the part of the pin.
And here I will introduce how the convolutional neural network works. Firstly, we will divide the output of image preprocessing step into 2 parts. One is the training set, and the other one is the testing set. The model will take the training set as the input and extract the features. Well, by features, I mean the factors that consist of an image. The models will then study those features and then start making predictions, basically identify the defect types. The models we're trying to implement are MobileNet version 2, AVNet, and GAN. Picking MobileNet version 2 is because we don't have access to the actual models used by the company, and we know that the model that is currently in use is MobileNet v2. So we want to train our own version of MobileNet so that we have a standard model to work on. And AVNet, again, it's because they are related to the problems we're trying to solve, which are dataset problems and accuracy problems.
Thanks for watching. We look forward to speaking with you at the Team Advantest booth and sharing our results.